We'll see.
Right, isn't it funny how some of those work so much better than other ones?
I know. I finally went with kind of this like metallic mesh instead of the plastic, so I don't know. Yeah, it does look very similar. So this slide is an old slide, but I put it up here because you might want to refer to it to work some problems coming up. Okay. So by the way, over here, which one do you need to memorize? The top one, 1 inch, is exactly equal to 2.54 centimeters. Exactly. Okay, so let's do this one. Now, in your homework that you handed in, and in here on Wednesday, we did some problems. And I'm going to do the same convention where basically I start over here, I have some arrows, and we're going to end over here on the right side. Okay? This one's a little interesting. Of course, milliliters is metric and cups is English, right? If you go back to what I just gave you or whatever, I gave you the equivalency between quarts and liters, right?
In our notes.
Is that what it was in that box?
Gallon liters.
Gallons and liters. Okay, gallons to liters. So we're going to actually piggyback on that. Okay, so you know from gallons to liters, okay, but we're starting with milliliters. So, and we want to get to cups. So there's a few steps in between here. There's more than one way to skin this cat. You can maybe even look up the another equivalency. But I'm going to do it this way. We're going to go from milliliters to liters, okay, and then we're going to cross the empirical bridge, the metric imperial bridge, metric English bridge, okay, using the relationship in that box, okay. Is that an exact relationship?
Yeah.
It's approximate. That's right. There's uncertainty. It's 4 sig figs there. Okay, so now I bet, are you okay with what's the relationship between milliliters and liters? Usually students say 1,000, and then they're like, now which way is it? So, yeah. So make sure you kind of get your wits about you. 1,000 milliliters is exactly equal to 1 liter. Now, if you're like me, that last one, and I wouldn't put this on a test, I would have to think through it. Do you know how many cups there are in a gallon?
32.
I think that's fluid, huh? Actually,
There's 2 cups at a
there are
time.
16.
I said 30.
I did that on purpose. I'm not going to have this on a test, that last one on a test. Okay, the other 2 are fair game. Okay. I'd be like, I don't know. It sounds like we're in agreement. 1 gallon is equal to 16 cups. Is that exact? Yes, that's by definition. Perfect. Makes a difference. So we talked about Wednesday, what's the thing we want to convert? What's our first term? And I need to see, I've thought about this before. I have the ability to walk around. I need to see you guys writing these, and most of you are writing these in your notes. So, yep, the thing we need to convert is 275 milliliters. I put it over 1, but my 1's going to go away. Let's just go ahead and do it this way. Put it over 1. Okay, now my strategy was to make my milliliters cancel, get to liters. So I'm going to use this. So what goes on the bottom? 1,000 milliliters. Perfect. And what goes on the top? 1 liter. Perfect. Don't forget the units. All right. So now, if I'm keeping up with stuff that cancels, milliliters cancel. Now I want my liters to cancel, and I want to get to gallons. So what number goes in the bottom there? Yes, 3.785 liters. Perfect. Over 1 gallon in the top. Alrighty then. So things that have canceled, liters have canceled, and we're left with gallons. And now we want gallons to cancel, and we want to go to cups. So what does that last term look like? What goes in the bottom? 1 gallon in the bottom, and 16 cups on top. Cool. And so I've just kind of carried the numbers along, focused on the units. We're left with units of cups, which is totally awesome. Okay. So in your calculator then, it looks like 275 times 1s times 16 divided by, in the bottom, 1,000 times 3.785 times 1. I'm not going to do that times 1. Oops. Okay. So, somebody, Brave, tell me what your calculator displays.
11.62483487.
Okay, 11.6248. Get me started. Perfect. And of course, units will be cups. Did anybody else get that? I'm seeing yes. Cool. Thank you. We good with that? Okay, so we need to round it. So to round it, we need to look back at the stuff we multiplied and go term by term. So the milliliters, was there uncertainty there? Yes. How many sig figs? 3. Okay. Here, the 1,000, the relationship between milliliters or liters, what do you think? Exact. I'm not counting sig figs. How about here between gallons and liters? It's approximate. So how many sig figs? 4. Yep. Remember that kind of when they set up those equalities that you read, it's like exactly one gallon is approximately equal to, or is equal to approximately 3.785 liters. 3.7, yeah. Okay, what about the last one? It's exact too. Cool. So how do we need to round our answer? I'm liking it. So let's go 3. So what's the answer?
0.6.
Yep, 11.6 cups. Ma'am.
I don't know how, but I keep getting the decimal over someplace.
Really?
It's 1.1. That's what I got the first time I did it too.
And then you got something different? I forgot my calculator.
So far, no matter what I do, what I've done is 1.16248.
Okay, it looks like it looks like we're balancing our checkbook and we're kind of coming up with a factor of 10 difference.
Yeah, I got 1.1.
Okay. So are you okay with that, Robert? I am going to, watch this, surgically remove the decimal and put it right here. Is that okay? So it's 1.16. Is that better? Thank you. Thank you and thank you. Okay. So the answer is 1.16 cups. And actually, I'm kind of cool with that because if you think of the lab and 275 milliliters, that seems reasonable. 1.16 cups. Okay? Any questions about this one? I like it. Okay, here's the builds. All right, let's do another one. All right, so you read this, and sometimes one of the things all students and teachers combat is a little bit of anxiety when they're faced with story problems. Maybe not. Some people like these. Okay, but you just got to kind of read it a few times and kind of get comfortable with it. Okay, because you're like, I don't know what a rod is, so I'm not going to do this problem. But you have to do this problem. Okay, it says a rod is talking about length, and it goes ahead and says 11 yards is exactly equal to 2 rods. So you know what? I might read it a few times, but eventually, and you can kind of see it on the next few slides, I'm going to pull out these words, and I'm going to turn them into math. Oh, math. It looks like this, right? 11 yards is exactly equal to 2 rods. And we know what we can do with equivalency statements. Okay? And then it goes on to ask the question, how many rods is 2.50 miles? So on the next slide, you're going to kind of see some builds that do this. But basically, we are going to go from miles ultimately to rods. You know, and I kind of tease and I say, oh, you might want to go get a cup of coffee if you want to or whatever. But knowing that we have this link to make this happen. So you could, I'm not going to do it this way, but I bet you could Google and that you could come up with a relationship between miles and yards. You could.
It's like 1,783 or something.
Okay. But instead, do you know the relationship between miles and feet? 5,280? Yes. That's the route I'm going to go. So here in a minute, we're going to go from miles to feet, because I know that. 5,280 feet. And then we're going to go from feet to yards. Yards. Of course, that's a 3-to-1, right? 3 feet. 3 feet equals 1 yard. And then we're going to go from yards to rods using this thing. Does that make sense? Yeah. So that's kind of the deal of it. So, what's that?
I didn't get what was miles to 5,000.
5,280 feet.
5,280.
And it's here too. So what I just said looks like this.
Yep.
But not so, not so messy. Very good. So sometimes when students work these problems, they put the thing to convert somewhere down in the problem, but you'll always see in my answer keys, I always start with the thing I want to convert. So, if you end up doing that, that's okay. It's the communicative property of multiplication, right? Okay, so 250 miles over 1. We want miles to cancel. We want to be left with feet. So what does that ratio look like? Yes, I like that. 5,280 feet over 1 mile. Perfect. Then I want feet to cancel and be left with yards. So what does that look like?
1 yard over 3 feet.
Yep. 1 yard over 3 feet. Perfect. And then I want to be left with rods and yards to cancel. So what does that look like?
2 rods over 11 yards.
2 rods over 11 yards. Does that make sense? I'm liking it. So if we kind of let stuff cancel, miles have canceled, feet have canceled, yards have canceled, left with units of rods. So in our calculator, in the numerator, you're looking at 2.50 or 2.5 times 5,280 times 2, all divided by 3 times 11. All right, somebody, let me know what your calculator displays.
800.
800, is there anything else?
No.
Whoa, what a pretty number. Well, that's what our calculator displays. Isn't that okay. Is that what you all got? That sounds familiar. Yeah, so now we're faced with, we got to be smarter than our calculator. Let's look back at what we multiplied. So the 2.50 miles, is there uncertainty in that? Yes. So how many sig figs? There are 3. The relationship between feet and miles, is there any uncertainty there?
Nope.
It's by definition. Isn't that weird? I think that's kind of weird. Okay, so no uncertainty. Any uncertainty between feet and yards? Nope. Any uncertainty between the rods and yards? Nope. Cool. So we're looking at 3. All right. So how are we going to make 800 into 3 sig figs? Yes, there's 2 ways, and that's probably what I would do. Oh, sorry. So the answer would be 800 with a decimal. Shows 3 sig figs. Exactly. What about if we went with a scientific notation?
8.0 times 10 to the power of 2.
Almost 8.0.
0, yeah, 8.00 times 10 to the power of 2.
Perfect. Times 10 to the power of 2. Oops, naked number alert. So my units are rods, right?
Rods.
Yeah, rods. Okay? At some point, students are like, oh, it looks so easy in class. And then you get home to a problem, you're like, I have no idea. But you know what? You guys know that these are recorded, so you can go listen to them again and again and again if you wanted to. They are recorded. So, okay. We did good, 800 rods. All right. Switching gears a little bit. Again, lots of words. Let's kind of look at it. Anytime you see the word per, I want you to think divisor. Okay? So here they say they give the gas mileage of a car. So 23.4 miles per gallon. And I think I probably mentioned this before. I want you to start taking that per and taking what's ever before 23.4 miles, and either making a big divisor like that, which is kind of handy, or just a slash. Per. Now, do you buy this that it just says per gallons or per gallon? So actually that's per 1 gallon inferred. So 23.4 miles per 1 gallon would look like this. Cool. It's like a property. Does that make it's physical property of your car? Maybe it's a chemical property. I don't know, because you burned the. So anyway. Okay, and it goes on and it says something. Sometimes I don't even look at the words. I just look at the units. I see something like about a 68.1 liters. I'm like, oh, liters. Well, I've got liters is volume, right? Gallons is volume. So I kind of start to think about that. Okay. And it asks how many miles you can drive. So, I don't know, if you were just doodling this, you might kind of go like something like this. What's the question? I'm going to put it over there. How many miles? Question mark miles. Can you drive on 68.1 liters of gas? And actually, that's kind of what we're going to do a little bit. Do you see kind of backing up that actually the thing I circled up there, the gas mileage, I can plug that in here and I can get to gallons going backwards. Does that make sense? I can actually go, okay, I can get to gallons. And then can we get from liters to gallons? Yes. So, I mean, to me, I kind of look at it from both ends sometimes. So here's kind of the strategy then. Oh, before I talk about the strategy. So I said unpack that 23.4 miles per gallon, okay? We can also flatten it out as a physical property for this particular vehicle. That's not very good mileage unless it's a truck, which would be very good mileage, I guess. I don't know.
Yeah.
So, but sometimes we need to flip it. So I'm going to go ahead and write the flip version. So any of that is kind of fair game to be thinking about the information given in the problem with regard to that vehicle. 23.4 miles per gallon. There's all kind of possibilities. It's good to have possibilities, usually.
Just not too many. Or you come up with a lot.
I know, too many possibilities is not good. Okay, so here we go. Like I said, liters to miles. Okay. We can go from liters to gallons. That was in that box that I gave you. Do you need to memorize that? No. That would be silly, in this class anyway. And that's an approximate relationship. Okay? And here is the whole, we can go from gallons to miles. I know it's weird, you're going from volume to length, right? Gallons is volume, miles is length. But you can do that with the gas mileage. The 23.4 miles per gallon. 23.4 miles is equal to 1 gallon. Okay? And then that's it, right? Yeah. So let's go ahead and work the problem. It starts with the volume in liters over 1. Okay, what does the next ratio look like?
1 over 3.7.
Yep, I'm here and out there. You got it. 1 gallon over 3.785 liters. Perfect. All right. Now I'm ready to go ahead and execute that last one to get to miles. What does that look like? Yep. 23.4 miles over 1 gallon. Perfect. So, you know, it's a really good check to make sure. It's called dimensional analysis. It's called analyzing your units, analyzing your dimensions, so that your answer is right. So liters have canceled. Okay, gallons have canceled. Okay, and we are left with units of miles, which is where we wanted to be. So, can somebody tell me what their calculator displays?
Something in my calculator if I don't do it.
421.01? Oh, wait a minute, the top one, sorry. The 15, 15.
No, right.
Yeah.
Oh, I have to like do the top and then write that number down and then divide it. If I do it all at once, then my calculator gives me the
It's
wrong
mad.
answer.
Okay.
Yeah, because I've noticed that when I did the other ones. Like I tried to just do like 6.81 times 23.4 and then divide it by that all together and it gives me the wrong
That's a
answer.
good point. Are you hearing what she's saying? In order to get the right answer, she multiplies everything in the numerator, writes the answer, and then multiplies everything in the denominator, writes the answer in the bottom, and does one last division.
Yeah.
I think that's good. So
And
you got, I
that's
think that
what I
sounds
got
right.
right there.
421.001. Is that what it, does that sound
Yeah.
right?
Mhm.
Thank you. Perfect.
Would that though make my significant figures different though?
No, that won't.
Because if you go by the last problem you did.
The only way it could do something like with your significant figures, with rounding kind of, an extra rounding step is if you do an extra rounding step, is if you truncate it and then do the last division. You should carry over what your calculator displays and then do one division at the end. Or one rounding at the end.
That's what I did.
Yeah, that would be great.
But okay, when you do it, would you go by these numbers for how many significant figures, or would you go by these numbers?
No, you need to go back to the original.
Go back to the original.
Mhm.
Okay.
Yep. So speaking of, so how are we doing with rounding here? So is there uncertainty in the liters?
Yep.
Yes. So how many sig figs? 3. Is there uncertainty in the liters to gallons?
Oh, yeah, there is.
Yep. So how many sig figs?
4.
4. All right. So what do you think when they gave us the gas mileage? Is there uncertainty here?
Yeah.
Yeah. A lot of play in that number probably usually. So how many sig figs in 23.4?
3.
3. Now, are you guys okay with kind of by definition how we unpacked it? There's no uncertainty in that one.
Yeah.
Okay. Right, yeah. Okay, so 3 sig figs. It looks like we need to truncate it here. So what's our answer? I'm liking it. Very good. Yeah, and sometimes students want to put a decimal or not. Either way, it's the same. Either way, it's the same.
421 decimal.
Yeah, you can, the decimals, sorry, I moved. The decimal's optional.
Wait, so we don't have to have the decimal, or we do?
It's the same either way in this
Either way?
case, yeah.
Okay.
The one it wouldn't be the same is,
If it had zeros.
Exactly.
Zeros are ambiguous.
yes,
So if it has zeros, then you decide.
you have to,
You
yes.
have
I want your brain.
Okay.
Ambiguous zeros.
Zeros after.
I want your brain.
Sometimes I don't want my brain.
Yeah.
Yes, sounds like you're,
You should see all the question marks I got. It's too much.
well, hopefully you'll do so many of them, you'll just be like, oh. And this whole rounding thing, this factor label, this working problems using this method, we'll just keep working at it basically all semester. So sometimes I tell students, the sooner you get it, the less painful. So, all right, any questions? One more.
What the heck is a loon?
I know, a bird.
Is it really a real
Yeah.
bird?
A bird.
Yeah, it's a real bird.
Not like from like,
It's a real bird, yeah.
not like the one from Up or something?
Google it, yeah. No, it's a real bird. Cool. It's like a water bird, kind of, is it?
Yeah.
Waterfowl.
Probably the most famous thing about those is it was on that movie on Golden Pond.
Oh, it's a sad movie. On Golden Pond.
I've never heard of it.
It's good. It's good. Okay, so let's see what we got here. I see a slash up there. So, yeah.
Meters per second.
And so actually, here in a minute on the next slide, you see me unpacking that. And I'm basically going to go 14 meters in 1 second. And the reason I unpack it is so I can use it as a tool to kind of let things cancel.
Pretty fast.
Yeah, it is pretty fast.
I like how we walk that fast. I could enjoy the city.
14 meters in a second.
I know. And so just kind of doodling, it says how long in minutes. So actually, this is actually going to be at the end. How long in minutes? Okay. Will it take the loon to fly? And actually, I'm going to start with this 5.00 kilometers. Okay, this is a classic case where you just kind of look at what you've got, what you're starting with, and what you're trying to end up with. Okay, so notice I have kilometers, but I could get to seconds from meters. Okay, I could get to seconds from meters
You gotta
with
go
that.
kilometers to meters.
Exactly, but I need to get kilometers to meters first. Yep, and then use that to get to seconds, and then I got one more thing to get from seconds to minutes. So actually, that's kind of the approach you see right here. Okay, and this is your reminder slide that anytime you have like a per sort of thing, you can go with it just as it is, 14 meters per 1 second. Okay, you can flatten it out. 14 meters for this bird is equal to 1 second, which is very fast, yes. Or you can say in 1 second it flies 14 meters. I mean, it's all the same thing. However you need to use it. It's your call. All right. So this is kind of what I said a minute ago. This is our strategy. Now, you don't always, when you're working a problem, and I'm kind of harping on, show all your work. You don't have to show this part if you don't want to. Okay? But, yeah, but you can. And the more you do them, the more you'll be like, oh, I get that. I can do that. Okay, so from left to right, what's our first term going to be?
5.00.
Yes, 5.00 kilometers over 1. A really common thing that we all run into is we lose information from the problem to working it. So a lot of times students will just put 5 kilometers over 1. But it's 5.00 kilometers over 1, which makes a difference when we round. Okay, so what's the next term look like?
1,000 meters or 1
Yep, 1,000 meters over 1 kilometer. I'm liking it. The next term?
1 second over 14.
You got it. 1 second over 14 meters. Perfect. And the last one?
1 minute over 60 seconds.
Yes, 1 minute over 60 seconds. Awesome. So our kilometers have canceled, our meters have canceled, our seconds have canceled, and we're left with units of minutes, which is perfect. So who's brave enough to tell me what your calculator displays?
Really long number.
What?
I said a really long number. I don't know how much of it you want.
Okay, so, but that's, so 5.9523.
Yeah.
Thank you. You got that? Perfect. Thank you. 5.9523. We'll stop right there. And units would be minutes. Yay. All right. So, answer. Does that seem right to everybody? Cool. So, is there uncertainty in the kilometers? Yes. So how many sig figs? 3. Perfect. Is there uncertainty in the relationship between kilometers and meters?
No.
How about with the speed that they gave us? Mhm. So how many sig figs in 14? Very good. How about this relationship between minutes and seconds? Exact. Right, those are both exact. So we're going to go with 2, right? So we're going to lop it off right here.
It'd be 6.0.
I'm liking it. Does that seem right? 6.0 minutes.
6 minutes to fly 5,000 meters.
Go for it.
What do
There's
you think?
1,600 meters in a mile,
Oh, to be over there.
so 6 minutes.
A lot of work for that.
It kind of stuns me every time, even in math, when we do all this work and then it's
Yeah.
like this tiny little answer.
Yeah, you're right.
Man, I'm
It's like,
done.
well, how lovely. I agree.
Like, oh, I just pulled all the hair out.
Yeah, exactly, right?
So we are gonna, I agree. We're gonna skip the last example and we're gonna take a look at the problems that are due for Monday then.
Is that the next two that?
Next example
Right.
is the kilojoules.
Yes, it's a good one, but you're fine without it for now.
It's like 30 miles an hour.
Okay. So homework that's due are 2, but like they have multiple sections. Okay. So here's your assignment slide, and of course 69 and 71 were due today. So that means 73 and 75 are due on Monday, which hopefully won't be snowed out. I don't think we will.
No, it's supposed to have a heat wave this weekend.
I know.
Another blizzard.
So let's take a look at these. Some of them are more straightforward than others. So 73 has 4 parts. Just get in the habit of, let's pick on, well, how about let's pick on C. See how we're doing out there. Can you talk me
I
through?
did C yesterday.
You did this one
I
already?
accidentally did.
That's
'Cause I thought it
funny.
was 71C, and I was like, all right, 25. And then I looked back in my book, and I'm like, wait, oh, crap.
Okay, but your hint would be, this is length, right? What is the one length relationship you're supposed to memorize between the English and metric system?
Centimeter equals 2.54 inches.
Exactly. You're supposed to memorize between inches and centimeters. Okay, so that's your hint there. Can you get from yards to inches? Can you get from centimeters to kilometers eventually?
Yeah.
Okay. Don't forget exactly how we worked them in class today is how I need to see them. So let's take a look right quick at the next one. Here's 75. Now, are the answers in the back of your book? Yeah. Will you get any credit if you write down just the answer? No. But is it a good place to check? Okay. Every once in a while, and all teachers and students know this, every once in a while the answers are wrong. So don't blame me if they're wrong.
Oh, yeah, you're going to hear it if they're out.
Okay, that's fine. I got broad shoulders. Okay, so have a great weekend.
I found that out in algebra class yesterday.